Hello, Flat Earth researchers, debaters and debunkers. Sending up high-altitude balloons with cameras strapped to them is one way people have been trying to determine whether the Earth is flat or a globe for several years now. The thing is, these kinds of observations always fuel debate about camera lenses and visibility. And even if anyone thinks they see a bulge of curvature in front of them, they may unwittingly be creating an embarrassing scenario for themselves. You can already find footage taken from more than 30 kilometres high, such as the video by DogCam, in which the balloon reaches an altitude of 32,500 metres, and it certainly looks flat from up there. When globe Earth believers see this flatness, they'll argue that they see the horizon drop below eye level, but ask them to point at eye level, and they'll evade any attempt to get a specific answer. Of course, at such a height, the clouds above the Earth's surface have become the surface that we see, which gives us a fuzzy horizon that isn't as clearly defined as horizons at low altitudes. Then there's a high-altitude view of sunrise over Texas, which reached 109,000 feet, which is 1,000 metres higher than the DogCam footage at just over 33,200 metres altitude. Globe Earth defenders looking at the Texas sunrise footage might claim you can now see a slight bend in the horizon that they assume is curvature. But is it a trick of the light being circular, or is it something to do with the lenses? In the video titled GoPro High Altitude Weather Balloon to 105,000 feet, which is 4,000 feet lower than the Texas sunrise footage, we see extreme curvature. We know, though, that the bendy horizon in this case is caused by the wide-angle fisheye lens of the GoPro camera, which can show the horizon as convex or concave, depending on the direction it's pointing. In fact, it's well known among photographers that almost all wide-angle lenses, no matter how good or expensive, are prone to barrel distortion, causing horizontal lines to bend. The bends caused by the lens can be removed by de-warping software. The only other way around this is to use a camera with a rectilinear lens, which eliminates horizontal distortion but does so by stretching the image vertically. This report by high-performance lens maker Theia Technologies says that until recently only fisheye lenses were available for imaging ultra-wide fields of view, but fisheye lenses have high levels of barrel distortion, affecting resolution at image edges. Only rectilinear lenses provide ultra-wide fields of view and correct the barrel distortion inherent in traditional wide-angle lenses without losing resolution. And then it goes on to give some comparisons of wide-angle lenses with rectilinear lenses. Here in Figure 1 we see the image showing 3D stretching from an ultra-wide angle rectilinear lens. And as you can see, the car on the right seems to be quite stretched out. And then down here we have the views through a wide-angle lens. Compression reduces the object width the farther it is from the image center, reducing resolution. And then we see examples of rectilinear lenses in Figure 3, and it says the same views taken with a rectilinear lens show increased resolution towards the edge of the image. Nevertheless, when it comes to determining the shape of the Earth, horizons don't prove anything other than flatness. The apparent convergence we see is because of the way the lenses in our eyes work and how our brain interprets what we see. We do indeed see flatness even when the surface is rugged, because the sky and the surface we see in the distance is smoothed out in our vision. We just don't have the ability to see long distances in high definition. When we are at a low level, we see an apparent horizon not far in front of us. If we're looking across water or along a flat road, we'll see a line across the surface that may appear below eye level. This is simply a point in the distance where we cannot resolve the details of the surface, because the angle of incidence of our line of sight to the distant surface is too shallow. It's important to remember that most outdoor surfaces are rugged, even if they are flat. The surfaces of bodies of water are constantly moving, with wind, temperature and waves all playing a role in distorting what we see with diffraction. which is described scientifically as light bending around an obstacle or spreading out after it moves through a small space. Or, according to the BBC, the spreading out of waves when they go through a gap or past the edge of a barrier. So if you look across an artificially smooth surface, there is less diffraction and you can see further across a very smooth floor than you can across a rugged outdoor surface, but you will always eventually see convergence at your eye level. It is true, however, that our height above a flat surface determines the distance we see a horizon in front of us. If you gain height above the surface, you will see the distance to the horizon increase. This has nothing to do with any assumptions that the Earth is curved, but it is exactly what we expect to see across a flat, level, albeit rugged surface, across which our view gives us an acute angle of incidence to the land or water in front of us. If we were standing on the surface with an eye level of about 2 meters high, we can see a horizon line on the surface about 3 or 4 miles in front of us, or all around us. Because flat surfaces never extend any higher than our eye level, the hard line of an apparent horizon that we see on the surface at low altitudes is simply a result of the surface getting squashed in our vision, because we have a shallow angle of view across it, compared to the transparent sky, across which we can see a lot further without any interruptions or obstacles. At this height, you might see ships seemingly sitting on the horizon. The assumption that horizons are because of the surface being curved is immediately destroyed, though, when you gain more height and see the horizon rise up with you to appear much higher than the ship that was previously sitting on the horizon. With more height above the surface, we simply see the surface appear to expand and allow us to see further because we have increased or expanded the angle of incidence to the distant surface, so it is no longer squashed in our vision. This repeatable observation is scalable, from looking across a tabletop to vast oceans, proving that we do not see the Earth as a fixed geometric form as the orthographic views of a globe model with tangent lines at angles would have us believe. We always eventually see diffraction occurring in the distance, creating a band of convergence between the surface and the sky, which is our personal horizon. Zoom in on any low-altitude horizon, regardless of the heat or cold, and you will see mirroring on the surface, beyond the apparent horizon. You'll also see that things on or above the horizon are distorted and cut off at the bottom, just as the bottoms of ships seem to disappear, and just as the sun gets cut off at sunset. These phenomena are always visible and easily explained with the science of light and optics, without any assumptions about the size or shape of the Earth whatsoever. Nothing is going down a curve, it is simply getting distorted by diffraction, making it impossible for us to see any further. When we get to high altitudes, we may well see what appears to be a gap or an assumed drop of the horizon below eye level, which is the centre of a forward-facing view. But this is merely a consequence of the increasingly dense air and clouds limiting the distance we can see with any clarity. Average visibility range in rural areas, regardless of any assumptions about the shape of the Earth, can be anywhere between 15 and 140 miles. So as we gain height, we do not see the surface clearly anymore, and so we do not see a clearly defined horizon line on the surface, especially when we are already above the clouds, which now become our visual floor, going off into the distance to merge with the sky and any other clouds above us. So, let's say we did get our hands on a pricey rectilinear lens to send up into the strato layer. Would we really expect to see anything that proves the Earth is a globe? Well, you have to think about what you would expect to see in a 360-degree view if the Earth was curved in front of you. If we look at a 360-degree sea view, we can see that the horizon is completely level all around. This again is exactly what we expect to see, a horizon at eye level when looking straight ahead. We already know that more height allows us to see further, but the apparent convergence of the sea and the sky will always be at our eye level, whether it is clearly defined or not. With this in mind, let's say that we send up a balloon with a camera that has a rectilinear lens and a bulge is seen in front of us and assumed to be curvature. So we see a horizon go from flat to curved like this. Thing is, this bulge creates a massive problem for globe Earth model pushers with this assumption that they are seeing Earth curve, which we can illustrate by lining up the shots taken in different directions for a 360-degree view. Let's go for a setup in which the camera or cameras face 4 directions: north, east, south and west, each with a 90-degree or more field of view to give us a montage of the surrounding view. With a continually flat horizon, we get a perfectly acceptable series of photos looking something like this, where the cardinal directions of south, west, north and east all line up nicely with an unwaveringly level horizon. Again, this is exactly what we'd expect to see in the real world with our own eyes. But regardless of what we're trying to prove, if we see a bulge in front of us in one shot, the same would surely be true for each perpendicular or 90-degree view, which would end up giving us a series of photos looking like this. In fact, if we were seeing a bulge of physical curvature in front of us in each view, that would mean the views in other directions would have to follow the curves seen at the edges to make a cohesive series of photos, which, as you can see here, make no sense whatsoever. We never see a high, bulging horizon on one side, accompanied by a low, sloping horizon on the opposite side. This is a simple thing you can prove for yourself on a plane journey by looking out of the windows either side of you. At 40 to 50,000 feet, you still always see a horizon at your eye level in all directions. So ultimately, sending balloons up or making any observations of horizons through telescopes and theodolites to assume you're seeing evidence of curvature is futile. You just become another victim of the mathematical trick to convince you live on a globe by converting the geometry used to describe perspective into an imaginary curve. The only surefire way to know whether we stand on or fly above a level or globular Earth is to make tangible physical measurements of the surface itself that are not open to interpretation based on one's preconceived beliefs. The dimensions of the globe model are fixed. We all know the formula of 8 inches per mile squared, based on the radius of the alleged spherical Earth, which should give us an easily measurable drop from horizontal of up to 70 feet across just 10 miles, or a drop of almost 8 metres over a horizontal distance of 10 kilometres. To date, though, no such measurement has ever been made. No one has ever measured curvature or even attempted to define a viable scientific method or experiment to make tangible measurements of Earth curvature, even though it could be done across a relatively short distance at a relatively low cost compared to the expensive expeditions to the ends of the Earth or the edge of space. If you are interested in the truth and believe yourself to be an advocate of scientific exploration, you won't be bamboozled by optics and perspective. You also won't fall for the mathematical trick of converting distances into degrees to Imagineer flight plans that follow imaginary curves and great circles around a conceptual globe. The physical flight data of straight and level flight always proves the globe model wrong against these claims of flying around a globe while twisting the definition of level to something that can only ever be illustrated and assumed, not measured in reality. Instead, a genuine truth seeker is only satisfied with a repeatable measure of the Earth's surface, which demonstrates a tangible difference between level and curved. Until then, the Earth is as it always has been, a level plane for as far as the eye can see. Thank you very much.